Esteemed viewers, in this tutorial, the while loop, another loop construct provided by C will be elaborated very clearly. It is mostly used, this while loop is mostly used whenever number of iterations are decided by a particular condition becoming false. It is rather conditional. While loop is rather conditional, unlike for loop where the beginning of the loop and the ending of the loop, the beginning of the iteration and ending of the iteration is known to the programmer very well beforehand. So whenever loop is controlled by a condition, then while loop is the candidate to be used. We will explain the flow of control as far as while loop is concerned. Control comes from elsewhere, from the top, and there is an expression, relational expression, that is being questioned. If the relational expression evaluates to be true, then statements under the while block will be executed, and it once again visits this condition. If the condition is true again, it will be executed. Like this, it will be executed as long as the expression yields the true value. Once the expression yields the false value or untrue value, then the control will be simply thrown out of the loop block and it will join the mainstream program. If the relational expression is true, then the statements gets executed in a very cyclic manner till the relation in the expression, the relational expression, works out to be false. How many iterations a while loop really works? Okay, for this question the answer is as many iterations as is needed for the relational expression to become false. Here we show the program equivalent. This is how the control flows. This is a flow chart of while loop, and here is a programming example. While expression is true, action 1, action 2, action 3 up to action n, any number of theoretically any number of actions, any number of executable statements can be placed within the while block. If at all the number of statements that is to be executed happens to be only one, there is no question of writing these flower braces, and only one statement will get executed repeatedly until this expression becomes false. Perhaps a very simplest loop is the one that never ends, while 1. While 1 means while true, while 2 means it is true, while 0 means it is false, while -1 is also true. Okay, this value could be either minus values or positive values, any value. Okay, and this is a straightforward loop that never ends. While such a loop is not used anywhere in computing circles, it is common in process control loops such as network servers, environmental systems, and manufacturing systems. A simple process control example that might be used to control the temperature in a building is shown over here. Please enter the temperature, and temperature is entered. If the temperature is less than 60, turn off the heater. Else if the temperature is more than 75, turn on AC. Else switch off. This is the one. Okay, until this will be executed repeatedly till the statement, till one of the expressions yields a negative, false value, but this doesn't happen simply. Therefore systems will be working cyclically, cycles after cycles. The loop to the right side will not execute at all because it starts with 0, while false, nothing will be executed. Okay, nothing will be executed. Therefore, since the relational expression is placed right in the beginning of the loop, this is entry control loop. This while loop is also called as entry control loop. Let us, okay, and we have written the first program. This first program as an example of while loop, a candidate program for an example of while loop is mentioned over here. This program will not let the user go until he or she enters a positive integer number. Okay, these two files are included as usual. Okay, main comes over here, integer number, the number is declared. Please enter a positive number only. Okay, the user is directed to enter positive number only. Let us say he enters a negative number or 0. then it will be questioned over here. While number lesser than or equal to 0, since it is negative, it is lesser than 0, therefore this will be executed once again. It should be positive number only. There is a guidance that comes through. Then the user may enter again a negative number. Once again this loop will continue to iterate and iterate over the time until it will never leave the user, okay, until he or she enters a positive number. Okay, if the user enters positive number, then this statement will be printed, thank you for entering the positive number. Then it will be there for a while on the screen because of getch. On the other hand, if the user straight away enters a positive number to start with the program, then the control will visit this. Anyway, it is not true, therefore it will come over here directly it will print, thank you for entering positive number. So this kind of a program should be written whenever the programmer is hell-bent on receiving a particular type of a number. Until and otherwise the user enters that requested number, the loop will not let him go. Okay, and this is another program which will count the number of zeros and ones in a given binary number. Okay, this comes through a logic. The logic is extricating or taking out the digits one by one. Okay, let us say if this is the binary number 101101, let us say. Anyway, this is a bigger number. It cannot be consumed within 8 bits. 8 bits or 2 bytes as a short integer, because this exceeds the limit of 33,000 plus. Therefore this should be declared as a long integer. Anyway, in the first step, okay, this one should be taken out. That can be done if this number is divided or done a modulo operation by 10. If it is done with a modulo operation of 10, okay, the remainder is 1. Modulo operation will always return the remainder. Okay, then the number is to be slashed by 1 digit. So by doing so, 1 is plucked. Okay, in the second iteration 0 is plucked. By then the binary number would have been reduced by 1 digit. In order to do so, this number is to be divided by 10. When this number is divided by 10, it will give us 101110, because anything beyond the decimal point will be truncated, because it happens to be integer division. Therefore, I repeat, the integer should be let in, and the last digit should be plucked one by one in different iterations, and before going to the next iteration, the number should be slashed such a way that it reduces by 1 digit from this end. This is the logic. Okay, modulo division by 10 and integer division by 10. Integer division reduces the number by 1 digit, while modulo division will take out the remainder. So here the variables are set for the long integer binary number duplication. This is for duplication, because in the process, binary number is going to vanish. It's going to wane away, because till it becomes 0. Therefore, this should be safeguarded in some other variable called as dupli. Integer bit, because bit is to be obtained upon modulo division, and this bit is to be examined whether it is 1 or 0. If it is 1, the 1 plus plus. This counter will be incremented. If it is 0, 0 plus plus. This should be incremented. So there is a guidance for the user. Please enter a binary number. The user will enter a binary number. It could be anything. It could be long integer. By declaring this binary number to be long integer, we will make this program little flexible, so that it will be able to take binary number of any length. While binary number not equal to 0, this is to be executed repetitively. We don't know when exactly binary number becomes equal to 0. Therefore, while loop is the candidate. Bit equal to binary number mod 10. Okay, in the first cycle, if this is the number, this particular expression, this particular statement will take out 1. If bit equal to 1, zeros plus plus. If bit equal to 1, 1 plus plus. So in the first iteration, 1 will go to, and this 1 before it was 0, now it will accrued 1. Then in the second cycle, this number, because this binary number is divided by 10, therefore it becomes 101110. Then once again it will be, because it is not equal to 0, once again this cycle will be visited and bit will be equal to 101110 mod 10. Once again 0 will be taken out because the division of this number yields 0 remainder. Therefore bit equal to 0, if bit equal to 0, zeros plus plus. Like this cyclically it will be done, and when it becomes 1, let us say due to successive slashing, okay, due to successive slashing we will say bit equal to binary number divided by 10. Therefore binary number that remains in that particular cycle is 1, 1 mod 10 is 1, and 1 will be added. And once again when we do this, 1 divided by 10 will become 0. Therefore the condition becomes false. Then for control will come out over here. Okay, so it is as good as telling, while the relational expression written over here is true, do whatever I say repeatedly, unmindful of how many iterations you have done. That's what we are dictating to the computer. When this particular expression becomes false, then the control will leave and it will come over here in the statement, to the statement which is immediately beneath the while loop. Okay, here number of ones and number of zeros will be displayed. Okay, number of ones and number of zeros in percentage LD. Percentage LD is the duplicate number which we have copied the original number in order not to lose the data. But one important point that we have to remember is, whenever we use the while loop, the variable that is involved in the conditional expression should be predefined. Otherwise there is no go. Therefore we have read this binary number initially, therefore this is defined, therefore it will be checked over here at the entry point itself. If this is true, if this is not true, it will be let in and it will be able to operate cyclically. So in the first succession we are going to operate with mod 10. Mod 10 will retrieve the last digit, any number, it could be any number. Okay, it will retrieve the last digit and it will be made usefully accounted. Okay, and in the second step is slashing that particular number by one digit by dividing the number by 10. And we know fully well that integer division leads to truncation. And this program is, once again, this program finds the sum of the digits of a given number. This also goes with the same logic. If number is 2, 3, 4, 5, first of all, let us say if the number is 2, 3, 4, 5, first of all you have to do mod operation in order to retrieve this 5. Okay, we will set forth a counter and we will add this 5 to the counter. Okay, counter will become 5 or sum will become 5. Anyway, we will name this particular variable with a suitable name. So counter will receive 5 and this number will be slashed to 234 by dividing this number by 10. Then once again 4 will be taken out and 4 will be added to 5. Then the number will be slashed to 23. Then 23, from 23, 3 will be taken out by doing modulo division by 10. Then 23 will be reduced to 2 by dividing 23 by 10. Then 2 will be taken out when we say 2 mod 10 equal to 2. There is one important thing that we should remember at this point of time. I want to tell you, my dear viewers, okay, if the numerator is n and if the denominator is m, this particular modulo division will generate the numbers from 0 to n minus 1. This is a very important thing that we should remember. 0 to n minus 1. Okay, if n is 10 and m is 20, if n is 20 and m is 10, then definitely this mod operation will generate 0 to 9 cyclically, whatever may be the denominator. The denominator will be 1 to m minus 1, 1 to m minus 0 to m minus 1 will be the thing that is generated due to modulo division. Okay, so modulo division is usefully taken over here to slash, to take out the last digit and to use it usefully depending upon the problem. And we have used the division arithmetic by 10 in order to slash the number by one digit progressively. Okay, so in this particular step, at a particular point of time, the number becomes 0, then the while loop stops. And since we don't know what is the number given to the given by the user and when exactly the program is going to stop, therefore the beginning is not known, the end is not known, therefore while loop is the candidate. Therefore this number of iterations is rather controlled by the number not becoming 0. If it becomes 0, the cyclic operation ceases to exist and we will get out with the answer. Okay, so I will repeat this by just reading this long int num, because this will facilitate any long number greater than 33,000 plus. Okay, duplicate in order to store this number, because in the melee this number will become 0. We are going to lose the data. Okay, so integer sum digits equal to 0. Okay, a variable name is befitting because we are collecting sum of the digits. Okay, if it is 2, 3, 4, 5, the answer should be 2 plus 3 plus 4 plus 5, that is equal to 14. Okay, clear screen is there. Printf, please enter the integer number. Okay, percentage LD number, ampersand number. Okay, number will come in. Duplicated number equal to num. Okay, it will be duplicated. While number not equal to 0, do whatever I say. So sum of the digits equal to sum of the digits equal to sum of the digits. So earlier it will be 0, 0 plus num mod 10. Num mod 10 means 2, 3, 4, 5 mod 10. 2, 3, 4, 5 mod 10 is 5. So what sum digits gets in the first cycle is 5. And num will become slashed by one digit. 2, 3, 4, 5 divided by 10 will be 2, 3, 4. It is not 234.5 because integer division leads to truncation. Once again 234 is not equal to 0, therefore it will be continuing. Some digits has already accrued at 5 and 234 mod 10 is 4. Okay, so 4 will be added to this. So 5 plus 4 it becomes 9, and this 2, 3, 4 will become 23. Once again 3 will be retrieved, so it will become 2, 3, 4, 5. 3 plus 4 plus 5. And once again what remains, 23 will become 2. Okay, and 2 mod 10 will be 2. Therefore sum of the digits will be equal to 5 plus 4 plus 3 plus 2, and 2 mod 2 divided by 10 is 0. So it is not equal to 0 is the condition. So this will become untrue, this will become false. Therefore immediately control will be shifted over here, and what we get is the answer that is being displayed on the screen. That will be displayed on the screen. Okay, the next problem is, this program finds if a given integer number is a palindrome or not. 3, 4, 4, 3 is a palindrome. 1, 2, 3, 4 is not. Okay, therefore similar kind of exercise is done over here. 3 is retrieved by mod 10 operation. 3 will be multiplied by 10, it will become 30. Then 4 will be retrieved, it will be made 344. 4 will be retrieved, and 30 it will be added to the previous 30. 30 it will become 34. It will become 34. Once again the number will become 34. Okay, 4 will be retrieved. 4 will be added to 430. Okay, it will become 434 because 43 into 10 will be done. So 434, and then 34 will become 3, and 3 mod 10 is 3, and 3 will be added to 3,440. So 3 will be added, and what we get is 3, 4, 4, 3 even after reversing, and the duplicated value is compared with the reverse number. If they are equal, then it is a palindrome, otherwise it is not. This is the simple logic of this particular example. So long int num, once again to facilitate a longer integer, duplicate. In order to duplicate the original number, reverse equal to 0. This reverse is a variable which will accrue the number upon doing modulo division as well as division by 10. So please enter the integer number. So number is entered. Let us say it is 3443. Duplicate equal to number. So duplicate will receive 3443. While number not equal to 0. Yes, it is not equal to 0. This will be the control will come over here. Reverse equal to reverse into 10. That is 0 into 10 plus num mod 10. Num mod 10 is 3443 mod 10. What it gives is 3. So number will become num by 10. It will become 344. Now what reverse contains is the earlier reverse. Earlier reverse was 3. 3 into 10 will become 30. 30 plus 344 mod 10, that is 4. 344 mod 10 is 4. Therefore it will become 34. Okay, it will become 34, and once again this will become 344 by 10, it will become 34. Now once again 34 will be multiplied by 10, it will become 340, and 34 mod 10 is 4. Okay, it will become 344. In the next cycle it is 344 into 10, 3440 plus num mod 10. Num will be there in that particular iteration, it will be 3 mod 10 is 3, so it will become 3443 again. Okay, and when 3 is divided by 10, it will give us 0, therefore the control will be shifted over here. Then duplicate will be compared with the reverse. If they are equal, okay, percentage LD is a palindrome, here reverse will go, so therefore 3443 is a palindrome. That will be the display, and LD is not a palindrome if this is not true. This is an example that is quoted again as quoted as an example for while loop. Now there is a famous conjuncture holds that all positive integers convert to 1 when treated in the following fashion. If the number is odd, it is multiplied by 3 and then 1 is added. If the number is even, it is divided by 2. Apply the above two operations to the intermediate results until the number reaches to 1. Okay, this is a conjuncture, and this while loop is the candidate. Okay, we will do that. If integer number I duplicate number, enter the number, so number is entered. Okay, number is entered, let us say it is 7 or whatever. Okay, duplicate equal to num, I equal to 0 because we have not gone to iteration, so I will be set to 0. Okay, while number not equal to 1. Okay, this exercise is to be done till number becomes equal to 1. Okay, we are just following the conjuncture, famous conjuncture. If num mod 2 not equal to 0 means, if num mod 2 not equal to 0, this is, we are testing whether the number is odd or what. Okay, is the number odd? We are testing this. Yes, if it is 7, yes, it is odd. Okay, we are testing this. Okay, then number is multiplied by 3 and 1 is added as per the conjunction. Else number equal to number by 2. Then it will carry either from this step or from this step, the number will be modified, and it is the completion of the cycle, therefore I plus plus. So here a counter is there, I, in order to count how many iterations it required for this number to become 1. Okay, that is the reason why this I plus plus is kept. So percentage D means duplicate number took percentage D iterations, that is I. Okay, whatever that I brings out after the completion of the loop is number of iterations. Okay, it took number of iterations to become 1. Therefore we will trace an example. Okay, it takes 15 iterations for 7 to become 1. Okay, let us see that. Okay, first so 15, 7 is there, so 7 mod 2 not equal to 0 because it's an odd number, so number will become 7 into 3, that is 21 plus 1, 22. In the first cycle it is 22. 22 is tested, so since 22 is not even, it is even, it will become number by 2, 11. In the second iteration it becomes 11. In the third iteration 11 is an odd number, 11 will become 34 because 11 into 3 is 33, 33 plus 1 is 34. Okay, in the fourth iteration 34 will become 17 because 34 is an even number. Okay, 34 by 17, okay, it is the fourth iteration, and 17 is an odd number, 17 into 3 plus 1, it becomes 52, 51 plus 1, 52. So this is fifth. Then 52 will become 26 in the next iteration, 26 will become 13, 13 is odd, once again 13 will become 40, 13 will become 40 because 13 into 3, 39 plus 1, 40, 40 will become 20 because 40 is even, 40 by 2, and 20 will become 10, 20 by 2, due to 20 by 2, then 10 will become 5, 5 is again odd, so 5 will become 5, 3s are 15 plus 1, 16. Okay, 16 will become 8. So okay, it will become 16 in that same cycle, and 16 will be subjected to the next iteration, it will become 8. 8 will become 4 in the next iteration, and 4 will become 2, 2 will become 1. Therefore 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it takes 15 iterations in order to make 7 to be equal to 1. Any number, any positive number you can try, and I suggest my respected viewers to write the program here, to translate this program into some by taking typical examples and to see whether this conjuncture holds good. So with this we will end the discussion for this particular tutorial. We will once again repeat while loop by taking some problems of little complexity and the problems pertaining to engineering and technology. Until then, bye.